This video is about differentiating expressions and functions using the rule for polynomials. Derivatives are a result of performing differentiation process on an expression or a function. So what we normally have is a function, okay, that can be expressed in different ways. We differentiate it, and then we get what we call the derivatives or the gradient function. So derivatives. So if we start off in the form f of x is equal to blah 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 for the function, then when we differentiate it, the derivative is called f dash of x. Okay, if we have the function in the form y is equal to blah blah blah, then when we differentiate it, we write the derivative as dy dx is equal to blah blah blah. But there's another way. If we have y is equal to so on, then you can also express it as y dash, which is the derivative of y. Okay, now I'm just going to state the rule so you know the rule now. So if n is an element of real numbers, so n is a real number where n is not allowed to be 0, then if we have f of x is equal to x to the power of n, then the derivative of f of x, which is f dash of x, is equal to n x to the power of n minus 1. So what happens is the index drops to be the coefficient and the power decreases by 1. In a similar way, if y is equal to x to the power of n, then dy dx is equal to nx to the power of n minus 1. Or you can write y dash is equal to nx to the power of n minus 1. Okay, and if f of x is equal to ax to the power of n, then because we have a multiple of a, then f dash of x will be a lots of nx to the power of n minus 1. Similarly, if y is equal to ax to the power of 1, then dy dx will be a lots of nx to the power of n minus 1, or y dash is equal to a nx to the power of n minus 1. So these are the rules that you need to remember in order to differentiate using the rules. So we're no longer differentiating using first principles. Okay, let's look at some examples. Okay, so y is equal to 2x to the power of 5 plus 7x to the power of 3. Because it's y is equal to, that means we're differentiating, writing the derivative as dy dx. So the 2 stays there. The power 5 comes down to be the coefficient. X to the power of the power decreases by 1, so it's x to the power of 4. Plus 7 stays as a multiple there. The 3 drops to be the coefficient. X to the power of decrease the power by 1. Okay, now if we simplify this, 2 times 5 gives me 10, x to the power of 4, plus 7 times 3 gives me 21, x to the power of 2. And I can't simplify anymore, I'll leave it like that. So that's A. I do B, y is equal to 3x to the power of 4, plus 5x to the power of minus 2, minus 3x plus 10. Okay, then I'm finding dy dx when I'm finding the derivative. 3 stays there, the 4 drops down, x to the power of decrease by 1 to 3, plus 5 lots of the minus 2 drops down, x to the power of, if you decrease the power by 1, you get minus 3. Minus 3, there's an invisible 1 there, so it's 3 times 1, x to the power. If you decrease the power by 1, you get 0. Plus 10, 10 is invisible. There's invisible x to the power of 0 there. So you're going to get 10 times 0, x to the power of minus 1, which disappears. So the thing to keep in mind is any constants will disappear. Okay, so if I simplify this, then dy dx will be equal to 12x cubed minus 10x to the minus 3. X to the power of 0 is just 1, so this is just equal to 1, so you get minus 3. And that can't be simplified anymore, so that would be your expression for the derivative. Okay, I'm going to go over here for C. Okay, you've got f of x is equal to 2x minus 1 squared minus 3 root x. Now I need to expand the bracket and write everything in index form in order to use a rule. So that is the same thing as 4x squared minus 2 lots of 2x, which is minus 4x, plus 1, minus 3x to the power of a half, because root x can be expressed as x to the power of a half. Now that I've got it all in index form, I need to find, obviously, the derivative, which is f dash of x in this case. So it would be 4 times 2, because the 2 drops down, x to the power of decreased by 1, so it becomes 1, minus 4, there's invisible 1 there, 4 times 1, x to the power of 0 by decreasing the power by 1. The constant disappears, so there's nothing there, and minus 3 lots of half x to the power of minus a half when you decrease the power by 1. If I clean this up, then f dash of x will be equal to 8 times x, because x to the power of 1 is just x, minus 4 minus 3 over 2, x to the power of minus a half. Okay, and the last one, which is D, f of x is equal to 6x plus root x over 3x squared. Now what you don't do is differentiate the top and differentiate the bottom separately and then combine it. That is incorrect. So what you do is instead you treat each part separately. So separate out the numerator, 6x over 3x squared plus root x over 3x squared. Then you have two separate terms that you need to differentiate. So 6 over 3 gives you 2. X over x squared is the same thing as x to the power of 1. Take away 2, which is 2x to the power of minus 1. And then you've got 1 over 3, so the numerical part is 1 over 3. X to the power of half divided by x squared is x to the power of half take away 2, which is x to the power of minus 3 over 2. Now that I've got in index form, I just need to differentiate it now. So it's 2 times minus 1, x to the power of minus 2, plus a third times minus 3 over 2, x to the power of minus 5 by 2. So because I'm dropping the power as a coefficient and then I'm decreasing the power by 1. Now if I simplify this, I end up getting minus 2 x to the minus 2 minus a half x to the power of minus 5 over 2. And I can't simplify anymore. So that's that. Okay, let's do some more examples. So again, we're differentiating. So let's call this A, B, C, and D. Okay, so f of x, I'm just going to use f of x in this case, is equal to 2x cubed plus 3x over root x, which means it's equal to 2x cubed over root x. So separate the numerator out, 3x over root x, and then write in index form so that 2 stays in the numerator, x cubed divided by x to the power of a half, because root x can be written as x to the power of a half, is x cubed, take away a half, which is x to the power of 5 over 2, plus 3, because 3 is in numerator, x to the power of 1 divided by x to the power of a half is x to the power of a half again. Okay, now a lot of students might stop there, but you don't stop there because obviously you still need to differentiate. You just simplified it into index form. So if you differentiate it now, okay, it's 2 times 5 over 2, x to the power of decrease the power by 1, which is 3 over 2, plus 3 times a half, x to the power of decrease the power by 1, which is minus a half, which gives you 5x to the power of 3 over 2 plus 3 over 2 x to the power of minus a half. So that was A. Let's just write A here. Okay, now B. Okay, B now. Okay, I need to expand the bracket. So f of x is equal to x times x squared take away x plus 2, which is equal to x cubed minus x squared plus 2x. Everything's in index form, so I can differentiate now. So 3 drops down, x to the power of decrease the power by 1, minus 2 drops down, x to the power of 1, plus 2 times x to the power of 0, which is just constant, so which is just 1. So if I simplify, I get 3x squared minus 2x plus 2. Okay, let's go to C next. So f of x is equal to 3x squared times x squared plus 2x, which is equal to 3x to the power of 4 plus 6x cubed when we expand the bracket. So now that we've got in index form, I can just differentiate. Is 3 times 4 times x to the power of 3 plus 6 times 3 times x to the power of 2, which simplifies to 12x cubed plus 18x squared. Last one is D. So f of x is equal to 3x minus 2 times 4x plus 1 over x. So I need to expand first. I get 12x squared plus 3 minus 8x minus 2 over x. If I write this in index form, I get 12x squared plus 3 minus 8x minus 2x to the power of minus 1, because x is in the denominator and x has an invisible power 1 there. So f dash of x will now be 12 times 2 times x to the power of 1. The constant differentiates to nothing. Okay, minus 8x differentiates to, because of the invisible 1 there. Here, minus 8 times 1 times x to the power 0. And the last term is minus 2 times minus 1 times x to the power of minus 2. If we simplify this, I get 24x take away 8 plus 2x to the minus 2. Okay, so that was that. Okay, next question. So f of x is equal to that. Show that f of x is equal, can be written in this. So we're trying to find it in index form. So if we write f of x is equal to 3 minus 4 root x times 3 minus 4 root x all over root x, and we expand it out, you get 9. You get minus 12 root x minus 12 root x, which is equal to minus 24 root x, plus 4 times 4 is 16, root x times x gives you x all over root x. And separate them out, which is 9 over root x minus 24 root x over root x plus 16x over root x. So the first term is 9x to the power of a half minus a half, because root x is in the denominator, so there's a negative involved, and root x can be written as x to the power of a half. Second term becomes minus 24, because the root x cancels out in the numerator and the denominator. And the last term is 16. X divided by root x is x to the power of 1. Take away a half, which is x to the power of a half. If I want to rewrite this in the form that they have it in the part A, then I get 9x to the minus half plus 16x to the power of a half minus 24, which implies A is equal to 16 and B is equal to minus 24. Okay, part B says find f dash of x. So f dash of x will now be equal to 9 times minus a half x to the power of minus 3 over 2 plus 16 times a half times x to the minus a half, and the constant disappears. So all I'm left with is minus 9 over 2 x to the power of minus 3 over 2 plus 8. 16 times a half is 8, x to the power of minus a half. C, it says evaluate f dash of 9. So f dash of 9 means I just need to substitute x equals 9 into my expression. So 9, where I see an x, I replace with 9 minus 3 over 2 plus 8 times 9 to the power of minus a half. Okay, now you can use a calculator, or you can do this in your head. 9 to the minus, square root of 9 is 3, 3 cubed is 27, and the minus means it's 1 over 27. And then you got 9 to the power of minus a half is, so plus 8 lots of, square root of 9 is 3, so it's going to be 1 over 3. Okay, the first term cancels down to minus 1 over 6 plus 8 over 3. I times by 2 and I times by 2. Then I get minus 1 plus 16, which is equal to 15 over 6. And now I can divide top and bottom by 3. So I get 5 over 2. And that would be my answer. Okay, next part. Find the gradient of the tangent to the curve at a given point. So if you're trying to find the gradient of the tangent, that means gradient function. So we're finding dy dx and then substituting the values in. So for the first example, we've got y is equal to 2x cubed minus 5x squared plus 7x minus 3. Then dy dx, let's do this straight away because it's already in index form. So 2 times 3x squared minus 5 times 2x to the power of 1 plus 7 times 1 times x to the power of 0. The constant disappears, which means it's equal to 6x squared minus 10x plus 7. Okay, so if you want to find the gradient, so you need to work out dy dx at x equals 1. Okay, so we're always substituting the x value. So that is 6 times 1 squared minus 10 times 1 plus 7, which means minus 6 minus 10 plus 7, which is equal to 3. So the gradient at the point 1, 1 is equal to 3. Okay, question 2. Y is equal to x minus 2 times x plus 4, which means y, if I expand it, I get x squared plus 4x minus 2x is plus 2x, and then minus 8. So if I'm finding dy dx, it's 2 times x to the power of 1 plus 2, which means it's just 2x plus 2. So if I'm finding dy dx at the point minus 1, 9, then I only need to substitute x is equal to minus 1 into here. So x is equal to minus 1 is equal to 2 times minus 1 plus 2, which is minus 2 plus 2, which is 0. So the gradient at the point minus 1 minus 9 is equal to 0. Question 3. You've got y is equal to x cubed minus 2x over x, which is equal to x cubed over x, which is x squared, minus 2x over x, which is minus 2. So dy dx will be equal to just x. When you differentiate x squared, you get 2x. Minus 2 differentiates to nothing. That's okay. So dy dx at the point x is equal to 2 is equal to 2 times 2. So you just substitute 2 into the expression for dy dx, which is equal to 4. So the gradient at the point 2, 2 is equal to 4. Last question that I'll go through. So f of x is equal to 12 over p root x plus x, where p is a real constant and x is greater than 0. Given that f dash of 2 is equal to 3, find p, giving your answer in the form a root 2, where a is a rational number. Okay, so let's write f of x. F of x is equal to 12 over p x to the power of minus a half, because root x is in the denominator, so it's going to be x to the power of minus a half plus x, which means f dash of x will be equal to 12 over p times minus a half x to the power of minus 3 over 2 plus 1, which can simplify to minus 12 over 2 becomes 6, so minus 6 over p, and then it's x to the power of minus 3 over 2 plus 1. Now what we're given is f dash of 2 is equal to 3. So because f dash of 2 is equal to 3, this means that when you substitute 2 into this, so minus 6 over p, 2 to the power of minus 3 over 2 plus 1 will be equal to 3. Okay, so when you substitute the x value of 2 in, you get a gradient of 3, so that's what the equation that you form. Okay, so now we need to somehow rearrange this to find what p is, yeah? So minus 6 over p, if I take the 1 over to the other side, then I get is equal to 2 so far. Now 2 to the minus 3 over 2 is the same thing as square rooting the 2 and then the cubing it. So you get, so let's write down, so you get square root of 2 cubed, which is going to be square root of 2 times square root of 2 times square root of 2, which is square root of 8. So you get 1 over the square root of 8 is equal to 2. Okay, so if you take it to the other side, the 1 over root 8 to the other side and multiply it, then you get minus 6 over p is equal to 2 times root 8, which can be rewritten as, if I go here, minus 6 over p, because root 8 is 2 root 2 is equal, so you can write it as 4 root 2. Okay, so that means p must be equal to minus 6 over 4 root 2. Now this, obviously we want it in the form a root 2, so it means I need to multiply top and bottom by root 2. So p is equal to minus 6 root 2 over 4 root 2 times root 2 gives me 4 times 2, which is 8. And I know I can see a multiple of 2, a factor of 2 in the top and bottom, so I can rewrite this as minus 3 over root 2 over 4. So p is equal to minus 3 over 4 root 2, which means a must be equal to minus 3 over 4.